Good morning, everyone, and welcome back to school. As you noticed, this morning I am gathering my 6th grade math teachers, and I am going to introduce to you the backward design, which is another way of creating our lessons to make sure that the students are getting the knowledge that they need in order to be academically successful. I am sure that a lot of you may have questions, and that's why I want to go with you selecting one of our math ticks so it will be easier for you to understand how this backward design works. So the past several years have presented many challenges for school teachers, including new curriculum and assessment expectations. For students, the going has been rough as well. So one strategy that has helped teachers who are asking questions about how these changes are going to affect us and what are the expectations for us this year and how are we going to align our standards to meet the students' needs. One of these strategies is this backward design model, which was developed by American education experts Grant Wiggins and Jane McTeague, and they encourage teachers to align teaching and learning activities and assessments to the knowledge and skills they want students to acquire. So that is what it is, backward design. We focus first on the desired learnings from which appropriate teaching will logically follow. In other words, we are starting at the end of what is our goal, what we want students to acquire at the end of our unit lesson, and deriving the curriculum from the evidence of learning. And, of course, we are aligning our teaching to the needs of students for tools and concepts to perform successfully in their subject. So why are we choosing this backward design? Well, one of the questions that we might ask ourselves when we are creating our lesson plans, as we have been used to, is, are we appropriately assessing what we are teaching? Are we sufficiently covering the key elements of our curricula? Are students acquiring the knowledge and skills they need to succeed in their post-secondary destinations? These are very important questions for us to ask ourselves and try to understand as the big picture of where we want our students to be at. If we want to pursue this successful career in them and understanding of the ticks that we are teaching, backward design is letting us start from that big picture of where we want our students to be at, what goals we want them to achieve, and from that big idea, start developing the activities, the concepts, the questions that should be included during our unit of study. So backward design has 3 steps. The first step is to identify the desired results, where we want to be, what is our goal. So what main understandings are desired on our students? What are essential questions that we need to include in our unit, in our plan? Essential questions may include providing direction and focus for inquiry, are asked over and over throughout the strand. They provide a base for building curriculum. They should be provocative and multi-layered. They serve as criteria for determining how well students are understanding. So how does it work? Let's understand it and its logic by analyzing this math tick that I selected, 6.8a, which says extend previous knowledge of triangles and their properties to include the sum of angles of a triangle, the relationship between the lengths of sides and measures of angles in a triangle, and determining when three lengths form a triangle. So this is what we want students to know. So step 1, as I say, identify the desired results, the big ideas or most important skills and knowledge as defined in the expectations and achievement chart of our ticks. In this case, we have this tick selected. So what should the students know? What should the students understand? And what should the students be able to do at the end of a unit and the lesson? These are called the enduring understandings. What main understandings are desired? Students and parents will be able to access notes, lessons, and activities from home directly aligned with classroom lessons from homework help. Students will connect classroom lessons to home activities and practice. Students will understand the importance of geometry in everyday life. Students will understand how to identify, measure, and classify various geometric figures. And students will understand the impact of having strong basic mathematical skills and be able to apply skills to various assessments. These are some examples of what we want them to understand. What is our desire of them to pursue? In our tick of geometry, this will be our desire, our goal. We want students to use a drawing of a triangle or a quadrilateral to find each angle measurement and classification. Want them to generate a model, example, a sketch or a computer generator, etc., of the drawing, and label the angle measure using measurement notation and the classification, if it's an acute, an obtuse, or a right angle, for each angle. And validate each measure by explaining the angle relationship and the problem-solving processes. So what are the essential questions that I need in order to pursue that goal? Some of the questions that should be included in my lesson will be, what is a triangle called with no equal sides? What do you know about the angles in an escalene triangle? What is a triangle called with two or more equal sides? What do you know about the angles in an isosceles triangle? What is a triangle called with all sides congruent? What do you know about the angles in an equilateral triangle? What is another name of an equilateral triangle? What markings show that sides are congruent? What is the relationship between the angles and the congruency marks on the sides of a triangle? How many degrees are in a triangle? How does having strong mathematical skills impact everyday life? The second stage, step 2, determine acceptable evidence. So what evidence supports student learning? And these are some of the things that we normally use every day at school, like tests, quizzes, worksheets, computer-based programs, journals, responses, projects, observations, participation. I have divided some of these into 4 classifications. School evidence. As a school, how do we verify that the students are acquiring their knowledge by end of unit tests, benchmarks, CBAs, report cards? In the classroom, How do you have evidence of them are acquiring their knowledge? By quizzes, journal responses, word problems, reading and completing geometry application, sharing responses with peers. As home evidence, notes from parents, complete homework. As student evidence from their own perspective, because we want our students to be responsible of their own progress. Classroom discussions and participation, independent work assessing progress and understanding. So in this second step, we determine the evidence of understanding. We articulate what it sounds and looks like when the students have acquired the important skills and knowledge. Then we determine how best to measure this achievement. These lessons should be authentic, should be open-ended and complex performance tasks or projects that allow students to use their knowledge in context. The focus of this step is the understanding. Teachers can use more traditional assessments, such as tests, to have a big picture of where the students are at. In assessing essential knowledge and skills that contribute to the culminating performances, we have formal assessment and informal assessment. Both of them are going to help us know and understand where the students are at. Now, the last step, number 3, is plan, learning experience, and instruction. And our big question here is, what knowledge and skills are needed for our students? What students know? What students are able to? Students can apply learning strategies and experience. We plan the teaching and learning activities that allow students to demonstrate that they have gained the required knowledge and skills. Which are those knowledge and skills? In our example today, reviewing that TIC 6.8, we're going to make sure that students in their knowledge and skills include triangle classifications can be validated by the measure of their angles. Relationships between the angles in triangles can be validated as the sum of the angles of all triangles as 180 degrees. Conjectures about a missing angle measure of a triangle can be validated and solved if 2 or other angles measures are known. When determining missing angle measures in a problem situation involving a triangle, a problem-solving process can be used to examine the known angles, make and carry out a plan to find the missing angles, and evaluate the angle measures for reasonableness. Now here you can see some of the references of backward design if you want to go further and read about it more. I hope that you like this explanation for today, and we will be working this year on training you more about backward design. Thank you.